What's up, AP Stats? Finishing chapter 13 notes, page 4 and 5. Actually, not finishing because we'll do 6 in class. But page 4 and 5 here actually have the most, what I would call complex and most important stuff of this unit. The actual rules that we'll be using for pretty much most of the probability problems. We have the addition rule and the multiplication rule. Now, before we actually jump into the rule, I want to talk about these little probability diagrams, I call them. They look very similar to Venn diagrams. I'll draw an easier one up here at the top. You don't have to draw this, guys, but down here we have two events, event A and B. If I just said like one event, maybe like, hey, the probability that it's going to snow tomorrow, and we just call this A. So inside of the circle, I would give you like a number. So it would be like maybe 20%, the probability that it snows tomorrow. And outside of the circle, remember, is what's called the complement. So the probability that A does not occur. So again, if I told you that the probability of A was 20%, the probability of the complement would be whatever adds up to 1. So in this case, that. Okay. Now, we will be talking mostly about at least 2 events. That's why these Venn diagrams come in more often than not with stats. So a lot of vocab here, so bear with me. The union of 2 or more events is the event that at least one of those events occurs. All right, so in the picture we have event A and event B, and we can see that event A can happen, that's over here. Event B can happen over here. They both could happen, right? Event A and B could happen. That's what this little middle piece is called. This is actually called the intersection. They could both happen, or just A could happen, or just B could happen, or neither of them could happen, which would be like out here in this little star region, like this purple. Okay, so the purple is neither A nor B happens. It's getting a little messy, guys. The green means A and B happened. This little like pink region means just B happened. And that looks pretty much the same. This lighter green means just A happened. Okay, so first part is like understanding the little Venn diagram here. All right, so when we talk about the union, we're talking about the probability that at least one of these events occurred. So if I said, hey guys, let's look at the union of event A and event B, we would denote that by this little U looking thing. It's not a U, but it looks like a U. It's this A union B. This is just the probability that either A or B happens. All right, and we'll look at this with the addition rule. So this is either A or B happening. So the union is A or B. And I'm going to jump right into the rule and then hopefully try to help you make sense of it through an example. So the rule, the probability of A or B occurring, which is the same thing as saying the union of A or B, can be found by adding. Now, what we're trying to find, guys, is the total probability of this, like, the two pieces combined in here. So like the A and the B combined. So whatever's not purple, basically. So the way we can figure that out is we can take the probability of A, which is, remember this little pink circle with the green shading. Then we can add the probability of B, which is this blue circle over here with like the pink on the inside and the green on the inside. But it's not as simple as that, because I think you guys can recognize if I just add that pink circle and then this blue circle, we're actually going to get more than we want, because this middle piece, this green piece, would be counted twice. So you take the probability of A plus the probability of B, and you have to subtract that little middle piece one time. And that is the intersection of A and B. And the intersection is denoted with this upside down U. It kind of reminds me of an N for intersection. And here is your addition rule. I would definitely have this somewhere. This is a very important rule when it comes to probability. Now, a lot of stuff there that maybe doesn't make sense right away, so I'm just going to try to recap what we have here. If I asked you, what is just the probability of A? Just the probability of A is what's inside the pink circle. Right here. If I ask you what's the probability of B, it's what's inside the blue circle. This little piece right here, this is called the intersection of A and B. And that is the middle piece. So like that is A and B happening. So what happens if we take the probability of A plus the probability of B and then we subtract the intersection? We get this whole thing, which I'm going to highlight right now. Let's try to do this in a color that stands out. I'm going to highlight this in gold. Didn't really help. Maybe I'll just do... That didn't help either. So this whole region right here is what the union is. I'll draw it over here. That's not it. So this shape is like A and B happening. This is the union, this whole thing. That is this. The probability of A or B, or the union of A or B. It's the whole thing. It's A plus B minus the intersection. Okay. Two events are disjoint or mutually exclusive if they cannot occur at the same time. So disjoint, mutually exclusive, means they can't occur at the same time. It would basically mean that the intersection, so the probability of A and B happening at the same time, is 0. I'll show you a little picture of this. So let's say I was at the high school and I said, hey, the probability that I pick a random student and that they are 15 years old, let's just say it's 21%. So here is 0.21. We'll call this event A. And then, so remember, this is the event that they are 15 years old. And then over here, I'll do event B. And we'll say that this is that they are 17 years old. And maybe there's more 17-year-olds in the building. So maybe there's actually a 25% chance. Okay, so here in this picture, I have 2 events. Well, really 3 if you think about it. Event A is that we have a 15-year-old, and there's 21% chance that that happens. Event B is a 17-year-old. There's a 25% chance that happens. And then on the outside would be that basically they're not 15 or they're not 17, so anything else. Now, if you notice, these two circles are not intersecting. Now, why is that? It's because the 2 events are actually disjoint, or what we call mutually exclusive. You can't have someone that is both 15 and 17. The probability of their intersection is 0. All right, so if 2 events are mutually exclusive, their 2 events don't overlap, there's no intersection. Okay, so this example, let event A be rolling a die and landing on an even number, and event B be rolling a die and landing on a 5. What is the probability of A or B? All right, so we see the word or. When you see the word or, think addition rule. And we're rolling a die, and we're looking at 2 events, right? Event A is even number, event B is landing on a 5. So I'm just going to use the addition rule, which says that the probability of A or B happening, which again is the union of B. I'm pretty much just copying this down. We can take the probability of A plus the probability of B and subtract the intersection. So let's think about this. What is the probability of event A? In this case, it said landing on an even number. Well, if I have a standard 6-sided die, we have 3 even numbers. We have 2, 4, and 6. So we actually have a 3 out of 6 chance for event A happening. Now to that, I have to add event B. So event B is rolling a die and landing on a 5. What is the probability that I just roll a die and it lands on a 5? Well, it's just a 1 in 6 chance. But now the addition rule says that we not only have to add those 2 things, but now we also have to subtract their intersection. Now the intersection, this is where you have to be a little thoughtful of what it is that we're asking. The intersection is the probability that they both happen. So in this case, event A is rolling an even number and event B is rolling on a 5. So what's the probability that we do both of those things at the same time? That we roll an even number and it's a 5. Well, we can't do that because 5 is an odd number. So the probability of rolling an even number and it being a 5 is 0. 0 out of 6. It's not possible. They're actually mutually exclusive. So if I take these, add my probability of event A, add my probability of event B, subtract the intersection, we get 4 out of 6. So we just used the addition rule. So the probability that I rolled a die and it was a even number or a 5, it's 4 out of 6. Okay, down here we have just a little more, I already explained this, the intersection of two or more events is the event that both of those happen. And I'll just highlight this. That's right here in the middle. That's the intersection. This is the probability of A and B happening. So if you see the intersection, we're talking about the middle. That's both A and B happening. Maybe I'll draw this right next to it so you can see it side by side. I'm just drawing the same picture, but if I did A and B again, oops, but then this time I asked you, not the probability that both A and B happen, but if I said, hey, what's the probability of A or B happening? That's the union. This is the addition rule. And this is not just the middle piece, but everything. Okay, so hopefully these two pictures help you make sense. All right, when we see the word or, this is the union. That's the addition rule. We're looking at this whole piece. Where this intersection is just like this middle piece. Within the addition rule, you actually have to subtract the intersection. The addition rule says A plus B minus the intersection. All right, next page, real quick. Multiplication rule, we actually have already done a couple examples of these. Pretty simple stuff. Multiplication rule is actually a lot easier than the addition rule. So what this says is that for two independent events, A and B, the probability that they both occur is the product of their probabilities. And here's what this looks like. So the probability of A and B happening, or in other words, the intersection, right? That's what we just talked about up here. This little piece. That probability can be found by multiplying the probability of A times the probability of B. So like this picture, if I wanted to find out, hey, what's this little piece in the middle, and I knew what all of A was and I knew what all of B was, I could just take A times B and figure out what's in the middle. That's a multiplication rule. Two events are independent if they do not affect each other. I'll give you an example. Tomorrow I'm going to pick an outfit to wear. And then tomorrow, Walmart's stock price can either go up or down. My outfit and Walmart's stock price are independent. They don't affect each other, right? Like, I don't care what the stock market does for Walmart, and they don't care what outfit I wear. They're not going to affect each other. Those two events are independent. All right, so here's a little example with this product rule, this multiplication rule. So we have a yellow die and a red die. Let's just assume that they're standard 6-sided die. So we have numbers 1 through 6 and 1 through 6 on this one also. Event A is the yellow die landing on an even number, and event B is the red die landing on an odd number. Now for this example, it doesn't ask us anything, but let's just say we're looking at the intersection. Let's say I asked, what is the probability that both of these happen? What is the probability that event A and B happen? Remember, when I say and, that's the intersection. This and looking thing. Okay, so for the intersection, this is the product rule that I just told you. We just do probability of A times the probability of B. Okay, well, event A says that the yellow die needs to land on an even number. Okay, well, there's 3 even numbers out of 6. So that's event A. Now remember, this is the multiplication rule. This one's up here. So we just did probability of A happening. Now we need to multiply that by the probability of B, which is a red die landing on an odd number. So here's my red die. Odd numbers are 1, 3, and 5. This is still 3 out of 6. Okay, so it's really 1/2 times 1/2, which will give me a 4th. If I just did the multiplication across, it still reduces to a 4th, or 25%. All right, guys, so a lot of stuff here. We will do more practice with this in class tomorrow. But product rule, multiplication rule, really try to understand these two